Welcome to Algebra 1. The learning goal for this episode is to learn how to factor polynomials using the greatest common factor. Recall that factors are numbers that multiply together to form a product. So, for example, 2 and 3 are considered factors of 6 because 2 times 3 equals 6. We use the same terminology for polynomials. Factors of a polynomial are polynomials that multiply together to form the original polynomial. We will use a variety of techniques to factor polynomials. The first technique we'll learn, which is also the one you want to try first when factoring, is finding the greatest common factor, which is also known as the GCF. Let's look at some examples. We want to factor this polynomial by finding the GCF. So we look at each of our terms in our polynomial. Usually it's helpful to just look at the coefficients first, then look at the variable parts. In this case, if I look at just the coefficients of 2 and 10, I notice that 2 is the greatest common factor of 2 and 10. Therefore, it's a factor of my polynomial. Then I look at the variable part of my terms, and I notice that I have an x squared and an x. The largest power of x that goes into both of those is x to the first power. So x to the first power is the greatest common variable factor of my polynomial. That means that 2x is my GCF for the polynomial, because it's the greatest common factor of both the numeric and the variable parts of my polynomial. Once I have my GCF, I factor it, which means I divide out my GCF 2x from the original polynomial. When I divide 2x squared by 2x, I'm left with just an x. When I divide 10x by 2x, I'm left with just 5. Therefore, I have 2x times the quantity x plus 5, which is factored form of my polynomial. Note that I can check this by multiplying it back out. If I distribute the 2x through the parentheses, I get 2x squared plus 10x, my original polynomial. If I've factored correctly, this will always work, since factored form is simply another form of the polynomial. It doesn't actually change it. In this example, I'm going to try to find the GCF of this trinomial. Therefore, I have to find the greatest common factor of all three terms. If I focus on just the numeric part, the coefficients, I notice that 8, -24, and 6 all have 2 as a factor, and in fact is the greatest common factor of those three numbers. If I look at the variable parts of all three terms, x is the largest power of x that will go into all three of them. Therefore, 2x is again my GCF for this trinomial. If I factor out the 2x from each term, that means I need to divide each term by 2x. That leaves me with 4x squared minus 12x plus 3. This is now factored form. Again, I could check this by multiplying the 2x through that and making sure I come back with my original. In this example, we're going to factor this binomial. 4 is the greatest common factor for the numeric part. Notice that while 2 is factor of both 16 and -20, it's not the greatest common factor. 4 is. We always want to factor out the greatest common factor. For the variable part, xy cubed is the GCF. It's x to the first because that's the largest power of x that goes into both terms, and y to the third because that's the largest power of y that goes into both terms. Therefore, my greatest common factor for this binomial is 4xy cubed. So when I factor 4xy cubed out, I'm left with the quantity 4x minus 5. So 4xy cubed times the quantity 4x minus 5 is now factored form of this polynomial. Remember, if I want to, I can multiply it back out and make sure it matches the original. Now for our guided practice section, we're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step, I'm going to prompt you with the question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. For this problem, first question is, what are we trying to do here? What we're trying to do is factor this polynomial. How do we do that? We do that by finding the GCF. Typically, we first focus on the numerical coefficients, in this case 6, -3, and 9. The greatest common factor of those three numbers is 3. Now what? Now we focus on the variable part. With x cubed, x squared, and x to the first, x to the first is going to be the greatest common factor. What do we do next? We combine the 3 and the x to get 3x is the greatest common factor of this polynomial. Now what? Now we factor out the 3x and get 3x times the quantity 2x squared minus x plus 3. This is factored form. We're finished. Let's try another one. What do we do first here? First, we find the GCF of the numeric part. The GCF for 10, negative 20, and negative 80 is 10. Now what? Now we find the GCF of the variable part. That would be x squared y to the fifth. What's the next step? Together that gives us a GCF for this polynomial of 10x squared y to the fifth. Now what? Now we factor it out. This gives us 10x squared y to the fifth times the quantity x squared minus 2y squared minus 8xy. This is factored form. We're done. We could, of course, multiply it back out and compare with the original problem to check to make sure we did it right. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll have to press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video and work out the problem, then press play to check. Please pause the video now. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare this to your work. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to factor polynomials using the greatest common factor. We did that by finding the GCF of both the numeric and the variable parts of the polynomial, then factoring it out. If we want to, we can always multiply it back out and compare with our original to make sure we did it correctly.